All right, Foundations of Algebra, week 3. We're going to talk about properties of exponents. It should not be too bad for you, but first, we have to talk about a ruler here. Okay, so because Miss Knox, was saying that the ruler didn't go so well in art, so let's just look at it. So this is my ruler, and it has centimeters on top, and then inches on the bottom, and a little bit of vegetable oil leaked onto it. Okay, should be good. So if we want to measure something like this starburst here, see the starburst? So I can measure it. I'm going to put the ruler right here, and then I'm going to start right at the mark before 1. And this starburst is 2 centimeters long. You see? So you have to start it right at the beginning of the ruler before the number 1. Don't start it in the middle because that's not how you use a ruler. Now we could also choose to use inches, but you see, I'm not going to use inches because this is less than 1 inch long. And then I have to talk about fractions of an inch. And why would I do that when I can get, 2 centimeters exactly? You get to choose the units. I also have a crab hammer. How do we measure this? Well, see, here's the thing. If you measure it diagonally, are you really measuring it, right? So we're going to measure it. You got to hold it straight. And then this guy is about, can't see it. I don't know. Can you see it? 15.5. So it doesn't quite go to the 16. So it's right in the middle. Sometimes I take my take the object away and then just mark it with my hand here. It's 15.5. Last one, a little tough measurement, is icebreakers that I found in the drawer. How do you measure this? Well, this is a circle, so we would want to measure the diameter. So I have to go through the center, and then, so I'm going to try to hold the top of the ruler at what I think is the center so that I can get the diameter. And it looks like I got about 7.5. I don't know. 7.5. So anyway, there you go. If you have any questions about using a ruler, then go ahead and ask, okay? Well, we're going to talk about exponents because it is there's the E in the PEMDAS, right? And the number 1 rule of exponents is don't make, let me show you the mistake that I'd like you to write down and then cross out at the top of your notes. And it is this. 2 to the 3rd is not 6, right? Because 2 to the 3rd is not 2 times 3. It is 2 times 2 times 2, which would be 8. So you can write that down. And then from there, we are going to talk about our properties of exponents. So exponents with integer bases. That means it could be positive, it could be negative. And if it is to the odd power, so write down -1 to the 5th. And then what is -1 times, let's write. So that means -1 times -1 times -1 times -1 times -1. And that is 5 negative ones, and 5 negatives means the answer is going to be negative. And what is 1 times 1 times 1 times 1 times 1 is 1, not 5, but just a plain old 1. Before you say this is so easy, there are some other things we need to talk about, but yeah, that one's. Oh, so let me just show you, like this one right here, okay? So this -11 squared, of course, that's negative. You would think is -11 times -11, right? But there are 2 different ways that we see this. We see that, and we see that. So this one is -11 times -11, which is +121. This one we think of as the opposite of 11 squared. Why? Because we had to write this some way, and so this is the way they write it, and so that would be negative 121. Okay, so before you be like, what? Doesn't make sense. Just know that there's two different, things that could happen, and so one of them is negative, one is positive. The one without parentheses is the negative one. Okay, if you got that, then you will have it. Now let's do the negative fractional basis. Is that really the next one? All right, very good. Okay. So now write down this title in your notes and write down this problem in your notes. Okay, so we see parentheses and squared, so we know our answer is going to be positive based on those integer ones. So what do you do because it's a fraction? Because it's a fraction, we think of it like this, either negative 1/4 times negative 1/4, or my favorite way, I like to think of it like this. The exponent can be thought of as distributing to the numerator and to the denominator. And then we just evaluate in the numerator, which would be positive 1, and in the denominator, which would be 16. So you can think of it either way, perhaps just know both ways exist. Okay, and then we should talk about a mixed number. Make sure that you can convert your mixed numbers to improper fractions. So how do we do that? We do the number times the denominator, right, plus the numerator over the denominator. How many people remembered that? And then the negative is out front, like that. So that would be 8, and then the 1 is 9. So it's negative 9/4 squared, which would be 81/16. Because 9 times 9 is 81, and 4 times 4 is 16. All right, so go forward with that. And remember, if there's a problem that's unlike the example that I did, that's going to happen. And if you figure it out, then make it a green question. If you are, make a mistake, but then figure it out, make it a yellow question. And if you can't figure it out, that's a red question in the organizer. Okay, so now we are on to multiply powers. So this is our, let me just go ahead and write down all the rules of exponents for you. And so this one looks like this. X to the m times x to the n is x to the m plus n. Example, x to the third, x to the second is x to the fifth. So that's called the product rule. There is also the quotient rule. So in the product rule, we add the exponents. You see that? What do you think we do in the quotient rule? We're going to subtract the exponents. And once you pause the video and see if you can write an example. Right now, I'm going to write it here. So this would be subtracting in my example. Would be like this. And so that would be 3 minus 2, which would be 1. And we could just write x, because if the exponent is 1, you don't write it. So this right here is 9 times 9 squared, which would be 9 to the first times 9 squared, which is 9 to the third. And notice it says rewrite, with the 9 to the n. So we'll do that. All right, now you see this one here. This one's saying 12. So write this one down. 12 squared times 12 to the 7th and x to the 9th. So have to be 12 to the 9th to make that in a true equation. Interesting problem, but you can do it. All right. On to power over powers. I forgot to do the power over powers. So you have the product rule and the quotient rule, but how about the power to a power rule? I'm really glad this one was next. I can't believe I forgot this rule. So this is, and it would be x to the m, the n is x to the mn. So this is the one that would be x to the 6th power. So there's adding the exponents, subtracting exponents, multiplying exponents, and no, you don't divide the exponents. There's no rule for that. But maybe there is, and it just hasn't been discovered yet. Or maybe not discovered by me. But anyway, add, subtract, and multiply. So this is multiply. So 4 times 2 is 8. So that n has to be 8. And here we see it's like exactly like my example. Look at that. Okay, so there you go. 2 problems in each one. In the quiz. I will not do the quiz. Why will I not do the quiz? Because it is this, it's just all of these. And I think it's just all of these. So you can do that. If you are good with all 4 assignments, then the quiz will not be a problem for you. And there you go. So try them all for yourself, post in the organizer, and we will be ready to start.